All right, the distributive property. Distributive property is something we need to know like the back of our hand. Very essential in what we do. Most kids have an idea. Um, the book teaches it well. There's some things that I like and things, that, of course, that I don't like. Let's go to the things I don't like so I can get to the things I like and finish kind of on a strong note. When you talk about the distributed property, it doesn't take very long before you come down in your book and they tell you, oh, the distributed property, and they give you this. Well, yes, you can do the distributed property there, but this is so much an order of operations problem. It is so much easier that way. It tells you that, oh, we can take this 7 is times this group because it's butted up against. Well, that's a distributed property. We're going to be multiplying this 7 to every single term inside, okay, the parentheses. So we have a little differentiation between combining like terms and now we're multiplying. So yes, this could be 7 times 4, which is 28, 7 times 6, which is 42, and 42 and 28 gets us 70. Well, yeah, that works, but it's so much easier to go 7 times 10 is 70, and really by doing the order of operations. All right, and I see a lot of kids do this on a much more difficult problem, many more steps, and just bomb it. It's not even funny. So I'd like to go on and let's do something different. The distributed property, as it's meant to be, in parentheses, we can't do anything. There are no combining like terms. So we've got to be able to simplify this guy, which means we got to distribute through multiplication 7 times a and 7 times a negative 1. Well, 7 times a is simply 7 butted up against a. Positive 7 times a negative 1 gives me negative 7. And that's it. That's the fundamental property of the distributive property. All right. From here, this basis of multiplying to every single term throughout the grouping process, it just gets longer. There's nothing really more difficult to it than that. All right. So let's get down the line a little bit. Okay, this is going to be a little bit more extensive than what your book does, but I think we have a pretty good basis for what we're doing and understanding of why we're doing it. Let's go n plus 4. All right, so basically the same setup as what we had previous slide. We're still going to distribute the n to every term, but we need to know a little bit of algebra here because when I take n times n, I get n squared. All right, and I don't think that's a huge jump for everybody. N times 4 is a positive 4n. So you see, we're doing the same things, but when we take bases times bases, in this case n times n, we add their exponents, and yes, their exponent is 1, and 1 makes 2. All right, so if we understand that, it opens up the door to vast amounts of what we can do in our distributed property. So let's take a look at another problem. Let's go, we all love fractions. So let's go 10a minus 4b plus 5. All right. And people freak out when it's fractions. It's not tough because we're simply taking tops to tops, bottoms to bottoms. So here we have a sign, a negative times a positive is a negative. 1/2 of 10, or 10 over 2, is 5. We get left with a. And it's extremely nice when we're multiplying by a multiple of what we're dividing by. Okay, so this guy goes in evenly. This guy also goes in evenly because 4 is a multiple of 2. A negative times a negative is a positive. 4/2 is simply 2. It is a b. And then a positive times a negative is a negative. And then 2 doesn't go into 5. 5 is not a multiple. Not a big deal. Tops times tops, bottoms times bottoms. 1 times 5 is 5. 2 times, and when we don't have a denominator, we always have a denominator. It's 1. So 2 times 1 is 2. And we're done. So don't freak out about the fractions. Please don't change it into decimals because you'll eventually get a fraction of like 1/6 or 1/3 or 2/3 where you round it. And we're not looking to round it. We're looking for exact things here. We don't want to lose any meaning whatsoever. Okay. Let's try another one. Let's go 2a minus 1, and let's go a plus 8. All right? Now, if some of you think back and we've retained any kind of knowledge, when we have a binomial, two terms, times another binomial, bi meaning two, right? Nomial meaning terms, two terms, this guy comes out to a cheat. I call it cheating. This is a trick because we haven't talked about FOIL before, but some of you have heard about FOIL. And what FOIL means is first, so I'm going to multiply my first, and I get 2a squared. Outside is simply my outside terms, so I get plus 16a. All right, now if we stop right there and look, this isn't any different than what we've done before. We've taken our term and we've taken it times every single term in the following group. Absolutely right. This is a distributive property. Okay. And then once we're done with it, we do our insides. Well, think about this. We've already done our first guy here. Now we're going to our second term, and our insides say do this guy, and our last say the last of each term. Well, really what we're doing is we're distributing the first term to every single term, and then we're going to come back to the second term and distribute it to every single term. And if there was more terms, we'd go back to it and distribute, go back again, distribute, etc., etc. So it's not a huge deal. Let's finish out this problem. Negative 1a and then minus 8. Now, when we do FOIL, not every time, but a vast majority of the time, these two guys here are the same term because they're both a terms. So we find the difference in this case because we're adding opposite signs. Difference of 15. They are a's, sign of the larger is positive, and then everything drops out. Now, I'm not a big fan of knowing tricks. I want to know why we do things and how they're done. In this case, you need to know FOIL. Okay, first outsides, insides last. This guy is what is termed a quadratic. And we will do so many things with quadratics in later chapters, later lessons, courses in algebra. It's unreal. Okay, and we need to know FOIL. We need to know how it works, the insides, the outs. Even though it's a distributive property, quadratics are around us in everyday life. Okay, population control, supply, demand, things like that. We kind of need to know that guy. So this is a trick that I still say we do need to know. From here it gets longer, but here again, don't confuse longer with being harder. Let's go another problem, x squared minus 2x plus 1, and yeah, I'm kind of cheating on this one. Save time a little bit. 2x squared minus 3x plus 7. And here again, FOIL doesn't apply. The distributive property applies, and the distributive property applies in FOIL, but we're just going to start with our first term. All right, I'm going to change my colors here so I don't confuse a lot of you. I'm just going to distribute it to each and every term. So we get x squared times 2x squared, which is 2x to the fourth, because we add our exponents when we multiply. Okay, then we take it times the next term, and I'm going to go ahead and draw my next arrow out there as well so I don't go back and forth between our colors too much. And we get minus 3x cubed and plus 7x squared. So that's all my red arrows. And then I move to this guy. And I do this to every single term. So 2x times 2x squared is a negative 4x cubed. Negative 2x times a negative is a positive, and 3 is 6x squared. And a negative times a positive is a negative. 2 times 7 is 14x. And now we have one more guy to do, and that's this 1. And this is kind of where I cheated, because anything times 1 is itself, right? So 1 times 2x squared, just simply 2x squared, and really we're just copying this down again. 3x plus 7. Now, notice how this problem got a lot longer. There are actually 9 terms that sit here, which means we got a darn good chance of those terms combining. Now, a lot of times you only get this 1, 2x to the 4th. Check and make sure, but we typically only get 1. Here's an x to the cubed, here's an x to the cubed, and as you see, I don't have any more. So when I combine things that are the same sign, I get that sign, add their absolute values, and apply their term. So there I have my x cubed terms. And then I come here to my x squared terms. I have a 7, I have a 6, and I have a 2, and they are all the same sign, so that's very beneficial. So I add their exponents, or add their absolute values. 7, 6, and 2 is 15, so that is plus, apply the sign, and they are x squared. Let's see, I need the blue one. Everything here is taken care of. I've got a negative 14x. I've got a negative 3x, which turns out to be a negative 17x. And then this last guy at the end is plus 7. So yeah, it's a longer. I'm going to buy that. Okay, I'll buy that it's longer. I'll buy that it takes more paper. I'll buy that it takes more time. But here again, I'm not buying that this problem is any harder than that problem that we began with. Okay? Distributive property. Make sure you know it inside and out, because we'll eventually start taking it apart, and you're going to need to know it. So good luck, take your time, and prepare.